Welcome to Saitechinfo channel. In this class, we will discuss toroid. The toroid is also known as toroidal solenoid. So it is a kind of solenoid bent in the form of closed ring like this. You know solenoid, that is a cylindrical turning of coil, whereas in the case of toroid, large number of turns of metallic wire is wound on a ring, that is torus, and that's why it's called toroidal solenoid, that is toroid. Now we can apply Ampere's circuit law to find the magnetic field both inside, that is at P, inside the toroid, and in the toroid, and externally at Q. So the direction of magnetic field inside is clockwise according to right hand thumb rule for circular loops. Now let us look at this toroid. As we have already indicated, internally we have got some points, that is P, they are represented by P, and Q, external points, that is outside the toroid. And we will be discussing in the toroid also. So let us call this is 1, the inside is 1, and the points inside the open space, that is 1, and then points inside the toroid, that is in between the coil, then points outside the open space here. So we'll be discussing the magnetic field influenced on these set of points 1, 2, 3. When we apply Ampere's circuit law, so first of all let us know what is Ampere's circuit law. The product of magnetic field and the length of the loop is equal to mu 0 into I. Mu 0 is permeability through free space. I, the current passing through the circular loop. L, that is the length of the loop, and in this case it is a 2 pi r, where r is the radius of the toroid. Now let us apply this magnetic field. We will try to find out the magnetic field based on Ampere circuit law for the three sets of points. One is internally in the space, empty space, then in the toroid, and third one is in the exterior space. What is the magnetic field? So inside the magnetic field it is 0, and in the external space also it is a 0. But in the case of second one, that is in the toroid, it is B is equal to mu 0 Ni, where you can find mu 0 being constant. So in this case we can say B is proportional to number of turns of coil in the toroid, and it depends on the current strength, that is current passed through, and it has no that is dependence on the radius. It does not depend on radius of the toroid. Okay, so this point should be noted down because no radius comes here after reducing the equation. Now let us see how these equations are derived in each case. Let us consider case 1 where BL, we are applying this Ampere circuit law. BL is equal to mu 0 I. So BL can be replaced by this 2 pi r. So B into 2 pi r is equal to mu 0 into 0. Why it is 0? Because every time that is a 2 the current passes through two times. One is acting inward, another is acting outward. They mutually cancel each other, so the current becomes a 0. Therefore B is equal to B into 2 pi r is equal to 0, then B is equal to 0. That is why there is no magnetic field inside the space, empty space, free space in the toroid. And second point, in the toroid, where we have in the toroid means that is on the coil, okay, inside the toroid. When I say inside the toroid means that is you have got the circular loop that is in the form like a ring ball, and inside that a ring ball. Do you understand? So we are talking about that one. So inside here, B into 2 pi r is equal to mu 0 into, and inside means that is in whole of the toroid, there will be n number of turns, total number of turns, capital N. So we have to replace this N and introduce this N into I, and B into 2 pi r is equal to mu 0 Ni. B is equal to mu 0 Ni divided by 2 pi r, and we already know N is equal to the total circumference into n number of turns per unit length, and it can be expanded. Therefore, B is equal to mu 0 2 pi r n. You can replace this n by 2 pi r n into I. So 2 pi r can be cancelled. Now you have got B is equal to mu 0 ni, where you can find mu 0 being constant. So it has got the dependency on, direct proportionality on number of turns. When you increase the number of turns, there is a magnetic field increasing. When you increase the current, magnetic field is also increasing. But it has no business with respect to what? The radius of the toroid. It is independent of the radius of the toroid. You understand? So the question may be asked like this also. How it is not dependent on, that is magnetic field produced by the toroid inside the, are you able to understand the meaning of inside? There are two inside. In the first case, empty space inside the toroid, and in the second case, space inside the loop of the toroid, the circular loop of the toroid. Do you understand that point? Okay, so we are talking about that one only. So it becomes what? Independent. So you may be asked such a question. Then let us come to the third part here. B into 2 pi r is equal to mu 0 into I 0. The same logic. That is, each turn of the toroid passes through twice the area enclosed by the Amperian loop. And therefore, so that's what we have expanded here. One is going inside, the dots are outside. Okay. So inside, outside, and the equal number of turns are, that is coming and going out of the, coming inside and going outside the paper. Is it not? So they are cancelling each other. So the current is equal to 0. Since current is equal to 0, the entire term becomes 0. So there is no magnetic field outside the what? Toroid. Outside the empty space of the toroid. You understand? Right.